what's going on, you guys, and welcome back to the channel. In this video, we're going to be doing some more FastAPI, however, a bit more in depth compared to the last videos. So we'll also be integrating SQL within FastAPI using SQL Alchemy. And if you're familiar with Flask, then hopefully this shouldn't be so much of a learning curve if you're new to FastAPI. But yeah, it's pretty simple in terms, especially in terms of code. Like we don't have to write too much. I think Python allows that anyway. But yeah, like as you can see here, we'll be creating users, and we'll also be creating posts. We'll also be making use of query parameters. So like here, we can specify like our parameters in our GET requests, and also with posts. We'll also be updating posts, deleting them, and getting like a post in general. So all the basic CRUD stuff, which is create, read, update, and delete. And yeah, also one thing to point out, as we'll be creating users, we won't be focusing on authentication. That I'm saving for another video, and I want to make this as clean cut as possible in terms of information. So it's mainly just basic CRUD functions in an API and how we can apply that with FastAPI and a database. But yeah, like hopefully you enjoy this video. The code for this demo will be in the description below. So go check that out if you don't want to hear me ramble. But yeah, hopefully you enjoyed this video, and now we'll jump to the code. So let's first start off by setting up the project itself. And to do that, we'll first create our Python environment. So I'll just make that a bit bigger, and hopefully you can see that. So what I'll be running is Python 3, Python 4, Python 3, -m, venv, venv. So I use virtual VM or venv for my virtual environment. And yeah, you can use whatever preference yours is. But in this case, I'll be using this, and I'll be naming it venv. So in order to activate it, we will do source venv tab bin activate, like so. And we'll see, or you should see the name of your virtual environment within brackets. And yeah, this is set up inside just create any directory or folder, and then just within that set up your virtual environment. Because now what we're going to do is create the source folder, and this is where our code is going to live in. So we can do source like so, and here in this like file viewer, we will see source, and I'm using VS Code. You can use PyCharm if you want, or whatever text editor you prefer. So within source, we will create the _init _init.py, and of course we won't be writing any code in here. I'll just make that a bit smaller and get rid of that. And now we can we'll first start off by creating our database, and for that we will need the SQL Alchemy. So we can do pip install. I'm using pip, so whichever package Python installer package you use, go ahead and use that. But SQL Alchemy, like so. SQL in capitals, Alchemy with A in capital, and then spell like so. Hit enter. And then we have it. And whilst we're at it as well, we can also install, let me just clear that. We can install FastAPI like so. So FastAPI, open square bracket, all, close square bracket. Now that's done, we can, let me just clear that. Just make that a bit shorter. So we'll first go about creating the SQL Alchemy like database, or like setting all that up for us to use later on. So to start with, we'll do import SQL Alchemy as _SQL. And if you've watched any of my previous videos, then you'll see how I import things and rename them with an underscore. The reason being is to keep these imports protected. So if you're using, like if your IDE or if you're using PyLint, then it will warn you that if you're importing something with an underscore, that you shouldn't be doing that as it's protected. And yeah, that's more of a preference. If you want to import SQL Alchemy and without that, then yeah, by all means, just make sure to replace where I put underscore SQL Alchemy, etc. So we can do import SQL alchemy.ext.declarative, and we'll name that as declarative. Nice. Yep, and then we will also import the ORM, so SQL.ORM as underscore ORM, like so. And yeah, so we'll be using SQLite. If you want to use Postgres, then yeah, by all means, there are just a couple slight changes. So to start with, we can do SQL Alchemy, capital Alchemy, database URL, like so, and we'll say SQLite. So we'll use SQLite, and we'll say dot within this within the source folder, create database.db. Oh, and yes, like down here in the bottom right, you'll see formatted black is not installed. I'm going to click yes on that, just to format my code in a nice way. If you prefer AutoPep 8, then go ahead, but I'm just going to hit yes. And if that didn't show up, then you can always just install black like so. So install black. And I recommend it. It just keeps your code in like a nice style format that's consistent. But yeah. So now that we have the URL, we're going to go ahead and create the engine, the SQL engine. So to do that, we'll say engine equals underscore SQL create engine. Create engine like so. We'll pass in the URL, and for SQLite, we need this like argument. So connect args, and I'll explain in a second. Check same thread. We'll set this to false. Yeah, so the reason why we need this is by default SQLite only allows one thread to communicate with it. And as we're using Python and we're making use of like normal Python functions, then we could have Python functions allow for more than one thread to interact with the database. And we want to set this to false, as the SQLite will have different threads, I guess, coming towards it. But again, like maybe my explanation wasn't clear enough, but I would definitely recommend reading up on that, as I don't want to go too deep into SQL Alchemy in this tutorial. So yeah, now that we have the engine, we can go ahead and start creating the session. So this session, we'll say, so session local, as it will be a class, underscore ORM dot session. My ID is pretty slow today, yeah, session maker, and we'll set auto commit to false. We'll also set auto flush to false, and we'll say we want to bind this to the engine, like, oops, like so. And yeah, this is a class, like it's not like, we'll use this as a database session. It's not a database session now, as we haven't created an object out of it, but we'll use this in the future to create sessions. And finally, we want to create the base, and I'll explain in a second what this is very briefly. So we say declarative base like so. And this is what we'll use as when we create our user model and our post model, will be overriding or inheriting from base. But yeah, that's really it. That's all it takes to 13 lines to create to set up SQL Alchemy, and from there, like, that's really it. We haven't created any databases yet. We'll go ahead now and create the model. To get started with our models, the first thing that we want to do is create our models.py file like so. And so if you're familiar with Django or Flask, then this is basically where we define our tables. So how we want our SQL tables to look inside the database. The other thing to point out is model. The word model takes a different form when using Pydantic. So as FastAPI makes use of Pydantic, which is kind of like a typing system for Python, which is a bit more stronger, then the word model means something else. But in this case, where it just means for our SQL table or tables. So we'll be creating two tables. So we'll create the user table and also the post table. To begin with, we can start by making all the necessary imports. So import SQL Alchemy as _SQL. And we also want the ORM from SQL Alchemy. So .orm as _ORM, like so. And we also want to make use of our base here. So this base that we created here, as we'll use that to inherit when creating our user and post models. So we can do import database as _database, and we can begin. So for the user, we'll do database.base, like so. And we can go ahead and add a name to it. So table name __. So these are two underscores here. And we can say users. Create an ID. So we can add SQL.column _SQL.integer. So we want this to be a primary key. So that's true, and index also to true as well. So now that we have the ID, we also want an email column. So pretty much how, like, if you've used Flask or Django, like I said, then this might be quite similar, especially if you've used SQL Alchemy in general, I guess. And we can say we want unique to be true, as we don't want the same email in our database. And we can also set index equaling to true as well. We can create a hash password, as we don't want to store our passwords in plain text. And also, just as a reminder, we won't, of course, be doing authentication in this, more so just CRUD and databases with FastAPI. So SQL.string, like so, and that's it. And we can also add an is active, so whether or not the user is active or not. And this, of course, will be a Boolean, and we can just set default equaling to true. So when a user is created, by default, is active will be set to true. And finally, we can do the post, so the post that the user has. And this will take the ORM.relationship, and we can say post, and this will be the name of our model, which you'll see in a second. And we can say back populates, and we want that to be owner. And now we can create the post model. So database.base, and the table name will be posts. We want the ID, same way we have the ID in the user table, in the user model, like that. We want to give it a title. String. And we want to set index equal to true there. We want the content. So this will be the content of our post. Set SQL to string as well. Index to true. We also want to add the owner of the post, so which user created it. We'll set owner ID as SQL.column. This will be an integer, and we also want to set this as foreign key, and the foreign key will be users.id. So why users? And that's because we've set the table name as users, so I'll look for that, and not user. So that's why we've put users.id. So now we have that. We'll add two more. So the date created, and this will be, of course, a date time, and we want to set the default to the time it was created. So we can go ahead and import date time as _dt, and we can set default equaling dt.datetime.utc now. And we can also add another one which is fairly similar, so date last updated, and that's because as we will also be updating our posts, it would be nice to have this information there as well, like that. And we can literally copy this for now, as we'll set the last updated to the time it was added by default, and there we have it. And finally, we can specify owner, and that will be the orm.relationship, and that'll have user back populates, and that will equal posts, like so. So basically, when we look at our user, as you'll see in the API, which will probably make it more clear, we will also see when fetching a user, for example, or users, we'll also see the posts that they've created too. So this is what this whole back populates does. Yeah, and that's really it. Like, we've basically created our models for this tutorial, which is the user and the post, and we have the relationship between the two. Next, we'll go ahead and create the schemas. So that's what FastAPI will be using to kind of as validation for the data it's getting, and for the data it's receiving, and the data it will respond with, or the format of the data at least. And that's what we'll go ahead and create now. So we'll now go ahead and create our schemas, or our Pydantic models. And the reason why I say Pydantic model is because there is a difference between a Pydantic model and also the SQL tables or the models that we've defined here in models.py. And yeah, all this will hopefully become a bit more clear. Schemas.py. And yeah, hopefully all this will become a bit more clear as we progress. So to begin with, we wanted to go ahead and create or import, or make all the necessary imports. As we'll be using Pydantic, we can import, so we can say from Pydantic, we want the base model. Actually, we could probably just do import Pydantic as Pydantic, like so. And we will use the base model that comes from it. So we'll go ahead and create our kind of like serializers. I think that might be the clearest way to put it. So this will basically shape the model or the data which the API will receive and the API will respond with. So that's what we'll do here. We want to kind of lay out what our responses and our requests will look like. So we can create our post. So we can create post base, and we'll use this to inherit later on. We can add an underscore, as this will be private to this file, or protected to this file. We can do Pydantic.base model, like so. And now we want the title, as title will always be in there, and we say set that to string. So we're not declaring anything, we're just setting the types. So when we'll have like a title, and that will always be of type string. We also want the content, which will also be of type string, like so. And now we can go ahead and create the like post create. So this is the data shape that we want when creating a post, and we want to inherit from post space like this. And these are just naming, like better ways to name it, so we're quite clear on what we're using when creating our API. And this will just be pass, as when creating a post, we'll only be sending the title and the content. Like, we won't send the ID because the ID doesn't exist, where we won't be sending like the date created or the date last updated, as that will be created on the fly, and we don't know that yet. So now that we have the post create, we can just create the post in general. So this is what we'll use to read. a post, and this will of course have everything else. So it'll have the ID, the title, the content, the owner ID, date created, and date last updated. So we can say like the ID will be an integer, the owner ID will also be an integer. So the date last updated, date created, sorry, will be a date time object. So we can also import that. So we can do import date time as underscore dt, and we can say underscore dt dot date time. Date last updated as well. So we can say that will literally be the same in terms of type. So that will be date time like so. And that's really it. And the last thing to do for this is to create our config class within inside the post class. And the reason why we're doing this is by default, the ORM mode is set to false. And we want this to be true because we want, when we are, let's say when we load our user, we want the post to come with it. If we look in our model, the user will hold posts, and we want that to show along with it. Like by default, like SQL Alchemy does lazy loading, and we don't want lazy loading here. We want to show the posts as well. If you were to use lazy loading, then in order to see the posts, you'd have to do something like user.posts, like so, in order to see it, and then it will go and fetch it. But with ORM mode set to true, it will fetch the posts as well, and that's what we want here. And all this will become a bit more clear. If you're confused right now, then hopefully it becomes a bit more clear later on. And now we can go ahead and create our user. So we can say class underscore user base, and that will take Pydantic dot base model. And here we'll have just the email. And then we can do class user create, and now inherit from user base. And that will also, that'll have both the email and password. So when we create a user, we'll be sending the email and password. And we can just set that to string. And finally, we can do user, like just the read one, the one that we'll use for reading a user. And what we don't want is the password. We never want to return a password. We do, however, want to return the ID of the user, which will be an integer. We want to return the email, and that will automatically be in there as we're inheriting from user base. We want is active, which will be a Boolean. And finally, we want the post that the user's created. And we need that to be a list, so we can import from typing, import list. And we can say that will be a list of a post, so this here. And we'll set that to a empty array if there are no posts. And we can also do class config set lazy, we don't want lazy loading, ORM mode to true. Yeah, so okay, so to kind of go over this, when we're creating a post, for example, what will we do when we send the body? It will have the title as we put past here, so it'll just be title and content. So we'll say title, this is a title, and then the content, like so, some content for the post. And that's all. When we create, that's the data we'll be sending. For like the post in general, like we can take this. So for this guy here, we'll be doing like it'll have the title and content, but it'll also have like the ID. I could say that's to 1. The owner ID, so like owner ID. Let's say that's owner 23, etc. And date last created, date last updated. And the same goes to that. So this is when we read a post, we'll get back like this, like that, along with date created. And then like, yes, that'll have a date in it. Like, I don't know. Yeah, and it'll have date last updated as well. And that's that's the format we'll get when we read a post. So date last updated, and that's what that will look like. And the same also goes for users. So when reading a user, we'll have the ID is active and post. When creating a user, we'll only be sending the email and password. And that's really it. And yeah, if this still isn't 100% clear just yet, then yeah, hopefully the rest of the tutorial, when we create the API, then that will become a bit more clear in terms of why is it that we're making these schemas and how do they come into play. But yeah, now we'll go ahead and move on to creating the API and getting everything up and running. So to start off with creating our API, we want to create two files. So the first one being main.py. And this will basically be where our API lives. And we also want to create services.py. And this is to just abide with service layer architecture. We don't want our main.py to have access to the database or anything like that. We want access to the services in main.py, and that will interact with the database. So it's like a middleman, services.py, between our API and our database. So to begin with, what we want is to make all the necessary imports. So we can import FastAPI as _fast API, and we can go ahead and create the app. So app equals _FastAPI.FastAPI, like so. And we can use this now as our decorator when creating our endpoints. And right now we don't have our database, we haven't created anything. You don't see a database file here either. So in order to do that, we'll create that within services. And so what we want is to import database as _database. And we can say create _database, like so. And we can return _database base meta data create _all. For some reason my ID again is slow, we're not seeing the autocomplete, but this should be fine. So this creates our database, and now we can go ahead and use that. So we can import services as _services. And we can say _services.create database. And what you'll see now is here in the directory, or the directory navigator on the left side of my IDE, you'll see database.db being created when we run the API. So to actually run the API here in the terminal, we can type in uvi main app, and then -- reload. So uvi main app -- reload, and the reload there just so when we save changes in our code base, the server will restart for us. Hit run, and there we go. We have database.db in here in the file navigation. So now we've created our database, we can now go ahead and create our endpoints. So the first one that we want to create is our to create a user. So we can do app.post /users, and we want the response model to be a user. So response model being so we need the schemas now. So we can import schemas as _schemas and say schemas.user. And so if you remember, in the user, we'll be displaying the email, not the password, because we don't want to return the password when reading a user, the ID, whether it's active, and the posts. So now we can say create user. And here, like with response model, like that's basically saying this is how the data format for the response of the API will be schemas.user, not the request itself or the information that we're sending to the API. And that's what we'll do here. So we want to send the user create when creating a user. So we want the password, the email and password. And we want to create our database session. So to do that, we need ORM. So we can import SQL alchemy.orm as _ORM. And we can say _ORM.session like so. And then we need to actually create the session. So we don't actually have a session right now. So within services, we can go ahead and do that. So to say we can do, so we want the database, so the database session, and the database will be represented as a session. So we can say the get DB, and the DB and the database equals _database dot session local. So remember this that we created, like now we're creating an actual session. We can add a try block here. So we want to yield the DB, the database. And no matter what happens, we always want to close the session off. So the kind of session we're having with the database. And so now we can do equals we want to depend on that. So it's our like dependency. We can do FastAPI.depends, and we can say services.getDB like so. And this isn't a function call. It's just .getDB _DB. And yeah, so that does seem like a bit of a mouthful, especially for Python. We're using types here. So user : will be of type user create. The database will be of type ORM session. And you can see if you highlight over it, it says the manages persistent operations for ORM mapped objects. It's basically like our database, like a session within our database. And that will be set to the database that we create here, like our session here. Like I don't want to go too much into this. This is more of a SQL alchemy sort of thing, but that's what we need. And we can go ahead and create the user. So we can say DB _user equals, and we want to create a service that like first checks. So we want to first check to see if the email that we send is already in use. So what we want now is to create a method that basically gets user by email, and this will take in again like an ORM session. So we want to import here. So import SQL alchemy.orm as _ORM. And we can say _ORM dot session, so it'll be of type session, and we also want to pass in the email like so. And this will return where we will return either if the email does exist, it will return like the user a user instance of that, and if it doesn't, then it will return none. So we can do return db.query _models. So we want to also import models as _models, and this will do models.user, and we want to filter by with the email. So we can say models.user.email, and whether or not that equals the email that we've passed in here, and we want to get the first instance of that. There should only be one, and we just want the first one. As filter will return like a list of it, we just want the first element. So now within main.py, we can go ahead and make use of that. So we can say database user equals services dot, it's not loading. My IDE is, I don't know what's wrong with it. Get user by email. think that's the name, get user by email, and we can pass in the DB as DB, and the email will basically be passed in as email equals user.email, like so. I'll just make this smaller. So yeah, now we want to check to see if DB user exists. Then we want to raise a HTTP exception saying that, like, okay, look, the user is already in use, and with the status code of 400 as like a bad request. So we can say raise underscore fast API.http exception, like so, and we want the status code to equal 400. And the message, so we'll say detail equals, let's say, whoops, the email is in use. Otherwise, we can just return, we can create the user. So to do that, we can go back to services and create a method that says create user. So we can do create user, and this again will take in like the ORM session, so a database session, so we can say ORM.session, and we'll also take in the user, which is from schemas, so we need to import schemas. Like so. And user create, because it will take in the email and password. And then from there, we can go ahead and create and hash our password. And again, this will be very, very weak. I do not recommend in any situation to use this as a hashing way, as hashing a password. Say, hey, fake hash password, and we'll say user.password, and we can say, let's put like a message, this is not secure, like so. And then we can create our user that we want to store. So we can say underscore models.user, and this will take in the email, which is user.email, and the hash password, which will be the fake hash password, like so. And then we want to add that to the database, so db add db underscore user, and we want to commit that, and we want to refresh on the instance, so db underscore user. And then finally, we can just return db user. And when we return that, this will be in the format of this response, so the user. So we'll read it and then format it so that it aligns itself with the schema. So it'll have an ID, email, as email is coming from user base, is active, and posts, and will not include password as we haven't included anywhere here. And finally, we can say return services dot create user, and we'll pass in the DB, which is this thing here, and the user as user. So yeah, hopefully this works now. We can go check it out. So as the server's already running, all we need to go to now is 127.0.0.1, and then the port 8000. And yeah, you should say detail not found. That's because we haven't created a root endpoint. But we can go, this is what I really love about FastAPI, is that it comes with this really nice interface. We can go to /docs. And there we have our interface with users, so we can interact with our API like this. So now let's try this out. Fingers crossed it works. So we can say email, and again, there's no email validation here either, but we can say something like john@gmail.com, password, this is some password. Execute it. We have an internal server error, and that is because yeah, it's this here, model is not defined. Let's just fix that. Models, and this is because my ID is very slow today, so I apologize, otherwise we would have seen that before. Hopefully everything else aligns. Let's just refresh this so we can try it out now. Email john@gmail.com, some password, execute it, and there we have it. We get our response, which is this thing here. So email, we get the email, and this is where the schema will come into play. So we've asked for email. Actually, let's just copy this here. If we go back to our schema now, we get our email, and as we're using user as our response model here, so schemas response model equals schemas.user, and .user is this bad boy here. So we get the ID, which we have. We get the email, which we get from user base as we're inheriting from it. We get is active is true, as we set that to by default to true, and we get all the posts. And because John@gmail doesn't have any posts, we get an empty array. So yeah, hopefully that makes a bit more sense now. But yeah, that creates our users. We can now go ahead and create some more endpoints for our user. So we can say like read users, and this is where we'll make use of like query parameters. So we can say app.get, again, this will be /users, same as before. And we want the response model to be a list. So we're getting all users, so we'll return a list of all the users that we have. And we can import that from typing. So from typing, import list. So list, and that will be of like the users. So we want .user, like so. We could also name this to user read, but I think user is fine here. I'm going to say read users, and we want to add a we're going to add query parameters, so the starting point and the finishing point, and we also want the ourselves to adjust it. So we can say skip, which is of an integer, and we can set the default to 0. We can set limit to integer, and we can set that to 10. And we also want the database session here, so we can basically copy that, but I just want to type it out. As like I don't want to make this look too busy by just copy and pasting it. So what we want is to pass in the ORM session, and that will again FastAPI.depends, and we can say services.getDB, and again not calling getDB. So now we have a read users. We can just put pass here for now. If we go back to our interface, hit refresh, and we get this, the get read users. And of course we don't, like, it doesn't work right now as there's nothing inside this endpoint. So we want to go ahead and create a service that allows us to get all the users. So this is pretty simple. We can go ahead, and say get users, and this will take in an ORM session like so. And we want to set these, we will also be passing in skip, which will be of type int, and the limit, which will also be of type int. And what we want now is to return all the users, so we can say db.query underscore models.user, and we want to offset, so the offset will be the skip, and we want to limit the amount by limit, and we can just say .all. So like if you imagine, just to quickly go over it, like if we had a list of let's say all these objects, or how to put it, apple, orange, and it's basically just like a array, like slicing arrays, pine, apple, and mango. The skip part is like how many do we want to skip. Because we've set this by default to 0, it will include Apple. If we were set to skip to 1, then it would go past Apple and start with orange. And the limit is like, where do we want it to end? And by default, we set it to 10. So that's our get users. And now we can make use of this service by saying, like within read users, we want to basically just return, we can say users equals services dot get users. And this will ask for our database session. So we say DB, which is this, skip equals skip. So like 0 by default, and limit equals limit, like so. And then we can just do return users. Or we could just put this all in one line, but just to make it clear. So now we have this working. So if we go back now, like remember we already created a user. So we can try it out, click try out, and we can leave that there. And there we have it. We have a list of right now 1 user. We can go ahead and create another one. So actually, let's try out, let's say if we were to use john@gmail again. So if we do john@gmail.com, I don't know, hello world, execute, then we get this, we get the 400 code, whoops, that email is in use. So we can try something else. So we can just clear that. We can say carol@gmail.com, execute. And then we have it. We get Carol. And now if we go back up to get users, we can execute again. And now we have Carol and John. And yeah, if we want to skip, so we could say like 1, execute, then we just get Carol because it goes past John. It starts at the first index, so index 1 instead of index 0. And also, if you're interested in like the URL or the request URL. We can set this, we can take this, oops, we can get this URL, open up a new tab, paste that in, and we get Carol. If we were to set skip now to 0, then we get all of our users, so John and Carol. But yeah, like this can be difficult to read, of course, and Swagger UI helps us with that. So now we have read users and create users. We can also just add another endpoint where we can read an individual user. So we can do app.get, and we could say /users, and then we also want to specify the user ID. So we're only returning like 1 user here. So we can say response model, schemas, and we want to use the user, and we can say read user, so not users but user. And as we're only returning like a single object, we can't really use query parameters for our list. So we want to pass in the user ID, and we want the user ID to be an integer, the DB session of course being _orm dot session, and we'll set that to FastAPI.depends services.getDB. Okay, and now we can go ahead and like get the user. So we can say we can create a service saying get user, and in order to do that, we can go ahead and say get user DB orm.session. And we also will pass in the user ID, which is an integer. And now we can query our database. So we can do return db.query models.user. I want to filter by the models.user.id, and we want to check to see if it matches with the user ID that we pass in. And we can do, we want the first one, as it will return a list. So hopefully that works. There's no typos here. We can go ahead now and say db_user equals service and we can say, because my ID is so slow, we can do get user, pass in the database and the user ID, like so. So what we want, so what if we pass in a user ID that doesn't exist? We also want to raise a 404 there, as in like not found. So to do that, we can say if db_user is none. So if it doesn't exist, we'll get a response from services as none. We can raise FastAPI, again, HTTP exception, like so, and we can say status equals 404, and detail we can set to sorry, this user does not exist. So I'm creating a very polite API here. Exists. So that's if the user doesn't exist. If it does exist, then all we have to do is return db_user, like so. So now we can go back, refresh. So we can say, not this one, sorry. Oops. In read user, we can try out and say 1. That should be John. Execute it. Then we get john@gmail.com as a response. We can do 2, which should be Carol. Execute. We get Carol. Now, if we were to do 3, what we should expect is a 404 and an error message. Execute. And we get an internal server error, which is unexpected keyword argument. Because this is status code. It's the problem. I'm blaming my ID here, IDE here, as it's not helping me do the autocomplete. I'm heavily reliant on that. But now if we just refresh there, we can try it out. Let's say like 5, which shouldn't exist. And there we have it. We have our 404 code and our little message saying, sorry, this user does not exist. And that's really it. That's basically the user created. Hopefully, like, there is a lot going on. I think a lot of it is also us doing the typing and setting defaults. That's why it looks a lot busier compared to like a standard Python methods. But I definitely like FastAPI, like really wants you to do that because it allows us to know, because we're using user create within user. If my IDE isn't slow, we can get the email, we can get password. But like if we were to do like .id, that wouldn't work because user create doesn't hold the ID. It doesn't hold like is active. If we would set this to .user, then we would. So if we go back here down to where we're using, so this one here, actually not this one, but if we were to set that to user like so, then we could do user.id is active, etc., which we don't want. We just want user create here. And that's why this is where Pydantic comes into play, as it's kind of like this type validation for our API. The data is getting and the data it will respond with. And to reiterate, this is our response model, so it will return a user. But when we send a user to create a user, we'll be sending the email and password, not ID or is active, because those things haven't been created. But yeah, that's basically our user endpoints created, so we can read users, we can create a user, and we can return like an individual user. And now we'll go ahead and create the endpoints for our posts. So we'll do creating a post, reading an individual post, reading all posts, updating posts, deleting posts, and that's really it. Yeah, and you also see within our users, you'll see the posts that they've created. So as we create a post, if we go here as like an example, within posts, we'll have like all the posts that a given user's created. But yeah, now we'll go ahead and do that. So to get started with posts, we can go ahead and start creating our endpoints. So we'll do a create post endpoint, and that will basically be app.post. And then /users user ID, because we need the ID of the user, and then posts like so, / and the response model will be schemas dot post, and this will be what was returned from, or how the API will respond once we've created a post. And now we can do create post, and this of course will take the user ID, which will be an integer. We want the post, which will be schemas dot post create, and finally we want the database to be orm dot session, which will equal FastAPI depends on services dot get DB. Okay, and we can just for now just put pass for now. What we want to do is first get the user, so we can to check to see like if that user exists. We want to return like a 404 or a 400, like a bad request. In this case, we'll just copy from above, so this here, and so we have the user get user, and we can say 404. Sorry, this user does not exist. And now we can create a service for creating a post. Oops. So below get user, we can say create post. So to create a post, we want to do get post. Oh, sorry, not get post. Create post. This again will take in the session and the post, which will be schemas.post create, and also the user ID, which is an integer. And to do this, we can do post equals models.post, and we want to unpack, so we can do post as a dictionary. So this will get the title and the content, we'll pass that in, and we also want to set the owner ID as the user ID. So now we've got our post. What we can do is just now add this to add the post to our database. We can say db.commit, and we want to just refresh on the instance of post. And finally, we can return post, like so. So yeah, pretty simple. And here, back in the main.py in create post, we can do return services.create post. And now we can set db the post, which will be post, and also the user ID, which is user ID, like so. Hopefully that works, there are no errors. We can go back to the interface, hit refresh, and we can see now that we have a new post, which is for creating posts. So create post, we can try out, let's say user ID 1. So for john@gmail.com, we set the title to "This is my first post." Maybe this isn't, yeah, I can zoom in a bit. To make it more clear, this is my first post. Hello world. As content, we can say hello world, I just wrote my first API using FastAPI. And now, fingers crossed, execute it, and there we have it. We have our post. So we have the title, it responds with the post schema, and there we'll have the title, the content, ID, owner ID, date created, date last updated. And there we go. And that's it. And if we go back now to, let's say we want to get the user and we want to get John, so we can say 1, execute. And now we can see here we have posts, and we get the posts that come with John. And this is where that whole ORM mode equals true comes into play, because it fetches a post as well. But yeah, that's basically the create post. Now we want to add some more endpoints. So we want to read posts, and this will be quite similar to this here, so the read users. So we could, yeah, let's copy it for now, and just make the adjustments. So get users, we don't want that, we want get posts. So we set this to posts. The response model will be a list of posts. We can keep the skip, limit, and the ORM session. And now instead of getting like the, change this to read posts, like so. So instead of getting users, we can instead create, well, we'll say pass for now, and we can create our service for getting the like the posts. So in services, we can do like a method called get posts, and this will take in an ORM session, and yeah, that should be it. Apart from like we want skip, and we can set we already set a default, so we could only set a default here. Limit, which is also an integer. So yeah, now that we have that, we can just do return db.query, and we want the post model, and what we need is the offset, so quite similar to this here. So we could let's not copy it, let's just add it in like so. So offset skip and limit, and we can do dot all like so, and that gets our post. And all we have to do now is back in main.py, we can just say posts equals services dot get posts, pass in the db equals db, skip equals skip, and limit equals limit, and we can just do return posts like so. And that's that endpoint working. So just refresh this, and we do posts. So this one here, read posts, try it out, execute, and we have a list of all our posts. So for now, just one, but that's that endpoint working fine. Now we can go ahead and read an individual post. So to do that, we need to create our endpoint app.get posts, and we can say like the ID of the post, so post ID, which will be post underscore ID. The response model will be the schema of posts. We can say read post, and this will have the post ID, which is a integer, the DB session, so we'll have again underscore ORM session equals FastAPI.depends services dot gets DB. So we can put pass here for now, and then back in services we can create a function that basically returns a individual post. So to do that, we can just do like a get post, so not plural, singular, and this will take in underscore ORM session and the post ID, which is an integer, and then we can return like a post with that ID. So we can say db.query models.post filter, and we want to filter for models.post.id equals post ID, so we want that, and we can just say first, and that should do it. So we can just return services.get post, and we say db equals db, and post ID equals post. Scroll down a bit, ID. We could also add like this here, so like a HTTP exception, and we could do a not found. So what we can have is we could actually set this to post if post is none. We can raise, just copy that. This post does not exist. Otherwise, we can just return post. So yeah, that should do the trick. So if we go back to our interface, we can now check it out. So if we do read post, and the ID of the first one is 1, execute, and then we have it. And if we were to do, let's say 2, execute, then we get our 404 error, and sorry, this post does not exist. So yeah, pretty simple, like quite repetitive to like the user. But now we can go ahead and spice it up a bit more by doing a delete request for posts and also an update. So we can say delete post, app dot delete, and within that we can say the post ID, same as get, and there we can do delete post, and this too will take in literally the same as like reading an individual post, and we want to delete it based on its ID, and let's just say pass for now. So yeah, if we go back, it's quite cool because it color codes it. So delete is shown in red. Of course, this doesn't do anything now, but it's quite nice to like categorize them by color as well. So now for delete post, we can go back to services and create a method that allows us to do that. So we can say delete post. Again, this will be underscore ORM dot session, and then post ID is an integer, and we can basically make use of that, but I just want to keep it like understandable. So we can say db.query models.post. Let's just copy this actually, and then we can filter by that. Instead of doing .first, all we have to do now is .delete, and the last thing we want to do is just commit that. And we can do this now. So in main.py, if we go back, we can go ahead and implement the delete. So we can say services.delete post db equals db, and then post ID equals post ID. And then we can just return a message saying like successfully deleted post with ID, and we can say post underscore ID, and there we have it. So now if we were to go back, hit refresh, in delete we can basically say we can try out, we can say post ID 1, so that's the one that we wrote, execute it, and there we have it, message deleted, successfully deleted post with ID 1. And if we were to go back to reading all the posts, try out, execute, we have no more posts. So yeah, that's that. We can go back and add a post now. I think it might be good to have one, so we can create post because we'll need it now for update. So let's just create a couple. So for 1, we can say a cool title, And for content, we can say some amazing content for this post. Execute it. Yep, that's now there. We can create another one. So we'll create another one for John. We can say, and what's really cool is that like you just have to adjust it and then execute again. So we don't have to keep going back. So we're going to create another one. So we can say, this is another post. FastAPI is awesome. Execute that. And then we have it. So if we go back to posts and we execute it, so now we have 2 posts. I mean, we could create other endpoints, so like all the posts. Yeah, like we could do like put and patch later on all the other fancy kind of HTTP requests we can make, but we'll stick to just basic CRUD. And yeah, that's really it. So we have 2 posts now. We can delete them if we want, but it's all good for now. So now finally we can go ahead and implement our last one, which is to update a post. So we can do app.put, and this again will have the same URL. Put that in. We can let's just copy this for now. So we can copy delete, and we can say update post. Post ID we want, DB session we want, and this we can put pass for now. So if we go back and if you look at the colors, now we have a put, so which is really nice in yellow. Yeah, it just looks really pleasing to the eye and makes the interface so much more understandable. Okay, so in the services, we can go ahead and create a method that allows us to update our post. So to do that, we can do update post. Again, takes in a DB session, ORM session, post ID, which is an integer. And what we want now is to get the get the post. So yeah, I mean, we didn't make use of it in delete post, but we could probably make use of it here. So DB post equals get post. Oops. And we can say DB equals DB post ID equals post ID. And then we can do DB dot title equals the what we want is okay, so we go back. I made a mistake here. So in update post, yeah, of course we want the post ID, we want the database, but the last thing that we want, or one thing that we want, I'll put it here in between. We also need the post, so post create. So schemas dot post create. Sorry, a bit tired. So apologies for that mistake, but we also want the post create because we want to update the title and the content. We also want to update, if we go back to models, the date last updated. However, we won't be passing that. That will be generated within like within the server. So we also want here the post. So we can say, I don't know where my head is, post create, like so. And there we have it. So yeah, now we also want post create. So in our services, what we can now add is so like DB post dot title, and we want post dot title, DB post dot content, and we want post dot content. And finally, we can just do DB dot commit. So commit our changes. We also want to refresh on the instance, so DB underscore post, and we want to return DB underscore post, like so. We'll go back to main. We can set the response model to schemas dot post. So we'll return the post itself. We also want to, before I forget, we want to change the db dot underscore post dot last updated. So if we go back to models, date last updated, and we can say we can import time, date time. So say import date time as underscore dt, and back down here we can say underscore dt dot datetime dot utc now, and that should work. So we can go back to main, and here we can basically say like we can just make use of the update. So we can just return underscore services dot update post. They want the database, post, this is post, and post ID, which is just post ID like so. So now, if I am not too tired and I haven't made any mistakes, there shouldn't be any errors when using the put request. So in put, we can say post ID. What IDs do we have? So we'll go back to read post, try it out, execute. So let's change this one here with a cool title. So we have that. So keep in mind it will be ID1 here, and we can try out, say ID1, and we set the title. I have updated the title. I have updated the content. So the desired response we want now, or the expected one, is a cool title will be changed to I've updated the title, and we also want, and the same goes for content, we also want to update this as well. So this should change. It shouldn't no longer match date created. So we can execute that, hopefully no errors, and we have an internal server error. I think the reason is in services. I think we can do now, like so. Hopefully that does a trick. If we go back, we want to output, and like I said, they are like, this video has kind of gone a bit too long anyway, like in terms of time. So if this doesn't work out, then I'd skip over the whole updating, last updated, but hopefully it should be fine. Updated title and updated content. Fingers crossed. And there we go. We have it. We have this working now. So the time's also adjusted. So this was created at 1:08, and this has now been created at 3:17. Yeah. So, and we've updated our content. So if we go back now to like get or read post, we can try out execute, and there we have it. Updated title, updated content, and that is working fine. So that basically concludes this tutorial. I know it dragged out for a lot longer than I thought it would, but hopefully if you followed along, then you have an idea of how to integrate SQL Alchemy or SQL within FastAPI, and also some of the basics around it. I'm thinking for my next videos to do some more content on FastAPI, on more of the basics, so without this whole database integration or like user authentication, and also jumping into other languages like Golang. So if you are interested in that, or if you want to see more content on that, please like and subscribe, and yeah, comment to let me know what you thought of this video, any feedback, and also what you'd like to see more of. But yeah, thank you very much. I hope that you enjoyed this video. Again, the code for this will be available in a Git repo, which I'll put the link in the description. So if you want to check that out, feel free. But that's about it, and thank you for watching.